Welcome to Startup DNA, where we look at the human side of the startup journey. Joining me right now is Dr. Palak Jain, co-founder and CEO of Vellex Computing. Palak, thanks so much for joining me.
Thanks for having me.
Can you tell me a little bit about Vellex Computing and what brings you to InnoVEX here in Taipei?
Yeah, absolutely. I am CEO and co-founder of Vellex Computing. Vellex is a semiconductor company. We are training AI models faster and cheaper than the cloud. So today, you might have likely heard about the cost of AI is becoming astronomical. Massive data centers that consume power more than the entire cities, or even the crazy talk of moving AI infrastructure into the space. So this is about two things: training and inference. Inference means running a pre-trained model on your device, like on your smartwatch or on your smart doorbell. But these devices, they can use AI capabilities, but they can't train AI.
Cannot train AI.
They can't train AI. For training, these devices rely on cloud. Training is the core activity that tells AI models how to recognize new patterns or predict new values. And it's heavy math. It's complex math. It involves solving complex optimization problems. And that's why it requires power-hungry chips that sits in the cloud and in data centers. And that's why we are building these massive data centers. So AI training is very expensive. To train even a basic model, it takes hundreds of thousands of dollars. Most startups, researchers, they can't afford it. And that's a problem we are solving. We are bringing ultra-low power AI training off the cloud onto your desk, faster, cheaper, and accessible.
Yeah, if it were more accessible, what happens then?
Then most of the devices, it will unlock their potential, because today, training is just logged into cloud and nobody can build their own models. Even a shop owner, they don't know how to train AI and they don't have access to cloud. So they can also increase their coffee sales by running AI within their shop, their coffee shop, just to keep track of what their customers, how their customer pattern is evolving, what their customers are ordering. So it just gives access to all the humans to use AI for their own benefit. And the key is to be able to make AI models fast. And that's why you require training. So we are democratizing that. So accessibility is the key for us to adopt this AI, and that AI should not be just logged within the cloud. It's only privileged people who have that amount of money, they can access it.
Or big organizations.
Or big organizations.
And it ends up being dominated. Now and in a few years' time, probably the trend that it's going to go.
So they can just use Cloud Code and they can use our device and they can train their AI model the way they want, and they can just then deploy it within their coffee shop, if they are trailer, just to keep track of how their customer behavior is evolving. Even for a house owner, you can build your own camera depending upon your needs, just to do recognition, like who is entering your house, can make it more secure. So it's just like democratizing the access to AI.
From a consumer or even small business perspective, that sounds like AI utopia, where really everyone has that sort of access. What made you want to solve this problem? What's your background? You came out of Stanford, was it?
Yeah, so we spun out from Stanford in 2021. So yeah, it's a very interesting story. So grew up in India, and Delhi is a very polluting city, right?
Delhi, okay.
Yeah, so I was very disheartened seeing how the air pollution is contaminating the city I was born and brought up in, and I always wanted to do something. And I learned about renewable energy when I was a kid, and I thought we should bring more and more renewable energy into the world. So that's why I did my undergrad in electrical engineering. And I just fascinated by the grid. It's the biggest analog machine today. Everything is just voltages and current. It's the biggest machine, which is just transporting energy so that we can convert it back into light energy or air conditioning, whatever we want to use.
It's a grid system, but it's interconnected.
So analog computing. So analog is very close to my heart, because since childhood, I was very fascinated with electric grid and how we can make technology is more environmental friendly. And that's why I did my undergrad. And after finishing my undergrad, I always wanted to work with analog machines. So I was a power plant engineer.
Power plant engineer.
And then, but there I was working with So there I was just a power plant engineer, so I don't have a lot of insights into machines, like how they work.
Was this in California or in India?
In
or?
India, in India.
Okay.
So I was a power plant engineer, and there I was the project manager for a 10 megawatt solar power plant, and that was the proudest moment because I was a commissioning engineer for that, and that power plant is today running, generating electricity for 100,000 people. So I'm so happy.
You were literally holding the power.
Yeah, so I enable that. So like that's a key. And so therefore I love renewable energy. I love analog. And I thought to do further studies, and I went to Singapore for doing my PhD.
To Singapore.
And there I met my co-founder Jason Poon.
Okay, cool.
Yeah, so Jason was doing his PhD at UC Berkeley, and I was doing my PhD at NUS.
NUS is, of course, National
University of Singapore. And so my PhD, our PhD was sponsored by Berkeley Education Alliance for Research in Singapore, and that's how we both met.
Oh, okay.
And we did phenomenal work together. Like we published many papers, and if you see at Google Scholar today, most of our publications which are highly cited, like they have 500 plus citations.
Google Scholar, I'll have to look it up.
Yeah,
Okay,
so
cool.
it was a very fruitful collaboration. And while doing PhD, so we were developing computing technologies, controlling this grid, this analog beast, this analog machine. And at that time, we used a lot of processors, like very high-end processors, FPGAs, GPUs, and CPUs. And we just found they do good job, but as these grid is becoming it's getting more penetrated with renewable energy or the power electronic devices, which is again another kind of analog machines. These processes are not good enough in simulating those kind of systems. And so when we finished our PhD, so I always wanted to go into industry. So I went to work for AMD as research scientist in their labs, and Jason went to Stanford for doing his postdoc. We continued, and Jason invented this cool technology where we can use analog computing to improve the performance of these electrical grid systems.
Oh, okay.
So grid is analog. The control system, so he invented an analog computing machine. And when we both discussed it, and we thought, okay, this is a great technology. We should get it to the market.
And as far as that hasn't been done in that same form.
Yeah, because one is digital. Like digital has eaten the world. And I always wonder, Jason and I have been working with analog systems for more than 15 years now. So we love analog computing. Analog has its place.
Yes.
It should not be forgotten because we went to moon with analogs. But slowly, digital gets invented, and it just takes the analog out of the scene. But now with the AI, analog is looking at the engines. It's coming back again. And it's the analog.
Oh.
As these models are becoming big and big, Musro has already ended. The chips are getting 3D. You can't have more transistors on a single chip. So you are making 3D chips now. But with the current state of AI, it's just very unsustainable. If we want to democratize, I'm tying back. We want to make AI accessible for everyone. But with current state of chips, with just digital, we can't need a hybrid solution where both analog and digital should work together. And that's why we are very excited about Vellex Computing and about analog computing for using it for AI training.
Certainly something that I have not heard about very much. So what we're talking about here is analog intelligence for AI. Is that what it's called? Analog intelligence?
You got it. That's our tagline. And
Okay.
advanced
Okay.
AI with analog intelligence.
Okay. Are people receptive to that? Whether it be partners, potential partners, or investors?
Yeah, so I think all of these industry partners, they care about their own problems. So they don't care whether it's analog computing or not, right?
No.
They just care about whether they have this problem today. Now they train their models in cloud. When they deploy these models on device, then the performance of these models just go down because cloud has a lot of resources, but your smartwatch, it doesn't have as expensive a processor as it is in cloud, right? So the resources are very constrained for edge devices. So you have to really prune the model or quantize the model. And when you do that, the performance goes down and the model doesn't perform the way it should. So there is a need for on-device adaptation and fine-tuning. And that's where we fit in. So we are bringing that on-device adaptation and fine-tuning for edge devices. The models are quantized, models are pruned, and we are giving them capability to adapt these models or applications as their operating conditions change or their environmental changes with time. For example, if we put our Vellex Computing in a robot, then a robot which is working for 6 months will be smarter than a robot which is deployed yesterday, because it's just learning on the job because of our chip installed inside that robot.
It's fascinating. It makes me realize pretty much every day I still have so much to learn. We still have so much to learn both as a consumer sector and as an industry. We'll have to wrap it up here.
Absolutely.
Dr. Palak Jain, thank you very much for joining me on Startup DNA.
Thank you for having me. It's a pleasure. Thank
All the
you.
best with IC Taiwan Grand Challenge.
We're very excited about it because the whole manufacturing is here. So that just brought us to be part of. We can't miss. We have to be in the Taiwanese ecosystem if we are building a chip. So I'm very excited to be here.
I think Taiwan's ecosystem could use more ideas, more fresh ideas from outside of Taiwan, and that's what InnoVEX in the end is all about. Thanks very much.
Thank you.